Differentiation of implicit functions. So we have two kinds of functions, explicit and implicit. Now explicit functions look somewhat like this. So they are given as, say, y is some function of x. This basically means that if you know the value of x, it will directly lead you to y. Whereas implicit functions, they are written somewhat like this. So some function with variables x, y, and so on, they give rise to something else. So maybe some constant, which means that if you know x value, it won't directly lead you to y. For example, take the equation of a circle. So x square plus y square equals to r square. Now I can also write this equation by sending y to one side. So that would be r square minus x square root over. This equation looks like an explicit equation. You know, y is a function of x. Here also y is a function of x. While this equation is an explicit function. It looks similar to this, right? So that's what implicit functions are. So let's say we have an implicit function f of x comma y is equals to c. Its dependency graph would look somewhat like this. F depends on x and y, and usually in implicit functions, y again depends on one of the variables present here. So it depends on x. Now this sort of a function is an implicit function. Now in the previous video, when we had a dependency graph that looks like this using chain rule, we found out df by dx. So what did we get back then? If they ask us df by dx, that would be dou f by dou x into dx by dx plus dou f by dou y into dy by dx. This one gets cancelled, so we get dou f by dou x equals to, df by dx equals to dou f by dou x plus dou f by dou y into dy by dx. Now this implicit function f is equals to a constant. That basically means df is equals to 0, right? So this term is equals to 0. From that we get df by dy into dy by dx plus, this is dou, sorry, so this is equals to 0. So dou f by dou y into dy by dx plus df by dx equals to 0. And if I were to take dy by dx to one side, we would get like so. This is an important formula for implicit functions. Now let's say in the question they give us an implicit function and we're supposed to solve it. We can either solve using this equation, or we can also solve like the way we used to do in 12th standard. That is, now say this is our given equation and they ask us to find dy by dx. You can differentiate this equation with respect to x, both the sides, and then send dy by dx terms to one side and find out the answer. We can do both. So I'll show you how in the example coming up. So this is our question. Now this does look like an implicit function, right? So this is f of x comma y equals to some constant 0, and they asked us dy by dx. We can do this in two ways. One is by directly differentiating this whole equation with respect to x. That would be 2x if you differentiate this with respect to x. Now xy, you can differentiate it using product rule. So let's differentiate x. That would be 1 y plus, now you're differentiating y, so that would be x into dy by dx plus y cube. If you differentiate it with respect to x, we get 3y square dy by dx, that equals to 0. Now we're taking dy by dx terms to the left side and everything else to the right side. So we get x plus 3y square dy by dx equals to minus 2x minus y. So dy by dx is equals to minus 2x plus y by x plus 3y square. This is one way. And the other way, we got a formula before that was dy by dx equals to minus dou f by dou x by dou f by dou y. So partially differentiate this equation with respect to x. So you're treating y as constant. So this term would be 2x plus, you're treating this term as you're treating y as constant. So if you differentiate x, that is 1. So that would be y plus this whole term is treated as constant again, so a constant differentiated with respect to a variable, that is 0, and we have a negative over here, so minus by, now partially differentiate this whole equation with respect to y, so x terms are treated as constant, that would give us 0 plus x is constant, and you differentiate y, that's 1, so x plus 3y square, that gave us minus 2x plus y by x plus 3y square. Our both answers are same, so that's how you do these sort of problems.